grade advanced class. Let's go ahead and knock this out. I'm going to take all the odd ones. Find the value of x. If I found the value of x, I got to use that formula that we came up with for finding what is going to be the total sum of your angles. And we know that we're going to take the amount of angles, right? The number of angles, which is 4. We're going to subtract 2 from that. And that's going to give us 2. And we're going to multiply that times 180. That's going to give us 360. Okay, so we know that there's 360 degrees all around. Now we've got to subtract all these numbers from 360. So we'll add them together. I'm just going to use my calculator to do some quick addition here. We're going to take 59 plus 84, 59 plus 84 plus 126. 126. That's going to give us 269. We're going to minus that from 360, 269. That'll give us the sum of our last angle. So minus 360, you might be saying, Mr. Mendes, you did it backwards. I'm just going to get a negative answer that's still going to be my answer positive, so negative 91. So my answer would be 91, all right? 91 equals x. Oops, sorry about that. Number 2 is for you to do solve the inequality, graph the solutions. When I do number 3, I see that I'm going to have to combine my like terms on opposite sides, which means I'm minus 4 from both sides. When I do this, I got 3z that carries down, and it's going to be greater than 12 minus 4, which is 8. Now I got to divide 3 away. It's not a negative number, so I don't turn my symbol in the other direction. That means x has got to be 8 over 3. Oh, so it's got to be greater, sorry, than 8 over 3. So if I'm making a number line, I'll put one here. If this is 0, right? I don't even need to put that 0 down, really. I just need to put 8 over 3 there, right? 8 over 3. And since this is 8 over 3, and I know x is bigger than 8 over 3, first of all, I'm going to put an open circle because it does not include it, right? It doesn't have a line under it. And I'm going to shade in all the numbers that are bigger than 8 over 3, and that's really all I need to do. Number 5, much the same way, except over here, I'm combining a positive, a whole number with a fraction. But it helps to remember that we're still dealing with numbers, right? So when I take this number and bring it over here, it's going to be negative 1, right? And it helps to remember that 5 over 3 is really 5 divided by 3, and that equals 1 2/3. And when I turn it to 1 2/3, this is really easy to figure out, right? Because I'm just going to go ahead and minus that 1 away, and that leaves me 2/3. That's going to be equal to, well, sorry, not equal to. I got a little confused because of the equal sign that I put over here. So again, this is, we're subtracting 1. And that leaves us with 2/3. But I don't want to confuse this sign with this one. We're going to leave this as less than or equal to. And now we got negative 2/3 x. And that helps quite a bit because I know I'm going to divide by 2/3, right? Which means I'm multiplying by actually a negative 2/3. So I'll be dividing or multiplying by negative 3 over 2, the inverse. which means I'm going to multiply by negative 3 over 2 over here. Since I multiply by a negative number, my symbol has to be turned the other direction. X remains alone. I know that I've got 3 on the top, 3 on the bottom. I could turn them to 1. I got 2 on the top, 2 on the bottom. I could turn them to 1. And now I got 1 times negative 1, that equals negative 1. And 1 times 1, that equals 1. Negative 1 divided by 1 is negative 1. So x is greater than or equal to negative 1. When I make my number line, or when I graph this, I should say, I'm going to put my line here stating this is a negative 1. And since x is greater than it or equal to it, I'll shade in the dot at negative 1. Remember, it's greater than or equal to, so that means I'll shade in all the lines that are going bigger than that. All right, next I have number 7. You have number 6. 7 says, find the sample space of the experiment, randomly drawing a marble. So I'm going to draw one of these marbles, and then I'm going to replacing it back in there, and then randomly drawing another marble. Or drawing, in this case, means pulling a marble from a bag. There's your sample space right there. There's really not a need to write all this out, just a waste of time. You're going to have, I could draw a blue one, and if I put it back, get another blue one. I could get a blue one, put it back and get a red one, draw a blue one and get a yellow one. I could draw a red one and then put it back and get a red one, a red one, then a blue one, and a red one, then a yellow one. Or I can get a yellow one, put it back and draw the same yellow one, or get a yellow one and then a blue one, and then a yellow one or a red one. That would be my sample space. All right, you have number 8, I have number 9. It says find the sample space of the experiment. Randomly drawing a marble, replacing it, and then randomly drawing another marble. This time we got 4 marbles here. And much like I did with the other one, I don't plan to write all that out. There we go. I'm going to shrink it down here a little bit. As you can see, we can start off with a blue marble. Remember, if we replace it, we can draw that same blue marble. Or we could draw the blue marble, then yellow, then blue marble, then purple, then blue marble, then orange. And the same with every one of these colors. 11 says flipping a coin 4 times. If I flip a coin 4 times, well, I could first get heads, right? And then tails. Actually, I could get heads 4 times. Heads, 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 right? You know what? I'm going to grab the answers because I don't feel like making all those heads and tails. There we go. We see that we've got could be 4 heads in a row, 3 heads and a tail, 2 heads, a tail, then a head, 2 heads, 2 tails, 1 head, a tail, then 2 heads, 1 head, a tail, a head and a tail, and then a head and 2 tails and a head, or a head and 3 tails. And then the same thing with the tails, doing the same thing. All right, let's go to number, let's see, that was 12. That was yours to do, minus 13. It says do not do number 13, so we're not going to be doing that one, which leaves me number 15. And it says use a fundamental counting principle to find the total number of possible outcomes. Spinning the spinner twice. If I spun the spinner 2 times, what are the total number of possible outcomes? So since there's 1, 2, 3, 4, 5, 6, we know that we could take 6 times 6, that's the fundamental counting principle, right? Because if we're doing it twice, there's 6 possible outcomes, and then we've got another variety that, of colors that will go after it, including the original color, which would give you 6 more. 6 times 6 is 36. That means there are 36 possible outcomes. Okay, ooh, made that kind of big. Let's change that font to, let's try 16. All right, number 16 is yours to do. Number 17 says, you play a game with the card shown. You randomly draw a card, replace it, and draw another card. Okay, find the sample space. The sample space for, remember, you randomly draw any one of these cards, you put it back in, and then you draw another card. Okay, so it could be this Explorer and then draw the Explorer again, or it could be the Explorer, then draw the James Webb telescope, right? Or the Explorer and then the space station. It could be these in any one of these 5, and then you would do the same thing to all of those. So since, once again, I'm feeling a little bit lazy, I'm just going to go ahead and paste that in. And instead of going by the words, they went by the colors by the looks of it. And you see, you could have red, red, right? Or red, orange, red, blue, red, green, red, purple. Then you could do the orange, right? Orange, 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 blue, orange, green, orange, purple, orange, red, and so on and so on. Part B says find the total number of possible outcomes. Well, what are the total number of possible outcomes here? We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Or the easier way would be, we know that there's 5 possible outcomes. So when we draw it again, that's 5 times 5, which is 25. So that's the route I would go. Let's see. 5 times 5 equals 25. So there are 25 possible outcomes. All right. Then it says for C, what are the favorable outcomes of drawing the same spacecraft twice? The same spacecraft twice. So this is going to be a little bit more complicated. Using a table, if you put all these down here, you would be able to identify which ones they were. But I mean, when you think about the favorable outcomes of drawing the same spacecraft twice, every one of these are spacecraft, that would be, let's see, red, red, orange, orange, blue, blue, green, green, and purple, purple, right? So that's it. Let's see, if it wasn't as complicated as I made it out to be. Red, red, orange, orange, blue, blue, green, green, and purple, purple. That means there's 5 out of 25, right? 5 out of 25, which is, well, 1/5, right? 1/5, yeah, 1/5 of the time. All right, let's go to number 19. You have number 18 to do. Choose a method. You randomly choose one of the marbles, replace it, and choose a second marble. Name 2 ways you can find the total number of possible outcomes. Well, one way we know of is using, remember, taking one marble and replacing it for a second. So that's going to be 4 times 4, which is 16. Or you could just make a sample space and go ahead and look at it that way on that. So let's see. Finding the sample space and use the fundamental counting principle would be the answer there. B says find the total number of possible outcomes using the method from part A. If I use that, that'd be 4 times 4 equals 16. Okay. And which method do you prefer? I prefer the fundamental counting principle. All right. Let's go with, you have 20, I got 21, think deeper. It looks like the last one. You play a board game with a spinner. Here's our spinner. You spin the spinner each turn. how many outcomes are possible in 4 terms? Wow, 4 terms. So we're taking 3 possible outcomes, right? And I'm thinking we're going to have to go ahead and probably have that to a power of 5. And so I would put 3 to the 5th. Oh, I'm sorry. It's not 5. It's actually 4, isn't it? So that'd be 3 to the 4th power, really, right? Um, well, I know 3 times, this is equal to 3 times 3 times 3 times 3. And I know 3 times 3 is 9. And 3 times 3 is 9. And then 9 times 9 would give me 81. So 81, right? I mean, in 4 terms, 81 possible outcomes. Okay. Um, this is not a repeating number. I know that kind of looks like that, where I just kind of realized that it was 4 instead of 5. How many favorable outcomes are there for spinning the same color 3 out of 4 times? We need to spin the same color 3 out of the 4 times. And to save me some writing and for you not to have such a long video, pasting the answer on this one. Okay, not letting, there we go. And I'm gonna have to shrink this a little bit. Wow, sorry about this. Wow, it did not exchange the program very well. So I'm having to get to the end here. Oh, there we go. Wow. So let's shrink all that. Okay, I'm going to bring this over here now. And we're going to shrink it again. Okay. Oops. And put that back over here. We're probably going to have to take this and not letting me do that. Wow. So once again, I'm going to have to shrink it. I'm just trying to get it to where it'll fit over here. There we go. And this might not have been the best method to use for revealing this, but the favorable outcomes of spinning yellow, 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 blue, yellow, 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 red, right? There's 3 yellows every time over here, right? It says favorable outcomes for spinning the same color 3 out of 4 times. So that would be for my yellow. Then that would be for my blue. That would be for my red. When you count these up, we got 8 times 3, which is 24. So there's 24 possible outcomes. Okay, don't do number or letter C. And looks like the rest of the night is yours. See you in the class for grading. Have a great night.